video presentation, I'll be talking about operators. So Java provides a rich set of operators to manipulate variables. We basically have 6 categories or 6 groups of such operators. We have arithmetic operators, relational operators, logical, assignment, miscellaneous, as well as bitwise operators. So let's start by looking at arithmetic operators. These ones are basically used in mathematical expressions in the same way that they are used in algebra. So we have the addition, we have subtraction, we have multiplication, we have division, we have modulus, we have increment, as well as decrement. Then the modulus operator, it basically returns the remainder of dividing 2 numbers. So for instance, if we have 2 variables, 55, say if we have 2 variables, if we have a variable 55, and then if we write something like x mod 25, the answer will be 5, because we are saying if we divide 55 by 25, we'll get 2 remainder 5. So mod basically returns the remainder. All right. So let me take you to visuals to NetBeans, so that you can see how we can use those operators quickly. Right. As you would remember, the plus, this plus, I also said it's called a concatenate operator when we are dealing with strings. But when we are dealing with numbers, this is an addition operator. So for instance, let's suppose we have int a, which is 4, and then we have int b, which is 5, and maybe c, which is 2, like that. But we can have I can write something like a is a plus b. This adds a to b and then stores the result in b. So if we want to see the result here, we can just do this. So if I run this one, it's going to show us the answer of adding a to b and then storing the result in a. Right. So the answer is 9, because what it has done is it has taken from a, we have 4, so that's 4 plus. In b, we have 5, so that's 4 plus 5, which is 9, and then we store the answer in a. So that's why it's displaying a 9 there. If it was multiplication, then we may have something like, say, a is b, c, right? B times c should give us a 10. So if we display what is in a, we should get a 10. So let me just run it and see what we will get. So we get a 9 for the first one, a plus b, and then we get a 10 for the second one, b times c. So that's the same with multiplication. That's the same with that's the same with subtraction as well as division. Now let's see the modulus operator, how the modulus operator works. So in this case, I want to store the answer in a, and I'm going to say b modulus c, like this, right? So b modulus c should give us the remainder that we get after we divide b by c. Now b has 5, c has 2, so we need the remainder of dividing 5 by 2, which should be a 1. So we can go on and display what we now have in c, and the answer should, in a, and the answer should be a 1. So we should see a 1 there, which is the remainder of dividing 5 by 2. And there you see we have a 1. So here we can have something like, say, the remainder of dividing 2, and then we do this, right? This plus that I've put here It's not an addition. It's a concatenate operator. We are combining two strings. We are taking this string and then we combine it to what we have in A. So it should show us the message, the remainder of dividing 5 by 2 is 1. Okay. Just in a moment, and there it is, like that. So those are basically the mathematical operators that we have. They work exactly the same way as they work in algebra. So let me go back and look at the other operators. Okay, so now let's look at compound assignment operators. We can combine an operation as well as an assignment. Like for instance, a statement like this one, B plus 20 is assigned to B. You see here we have a B and here we have a B, and between this B and what comes next, we have a plus. So we can take this plus, put it on this left side, and then just remain with a 20 like this one. So we say B plus, and then we assign it to 20. So this means take 20, add it to what is currently in B, and store the result in B. So in other words, we are saying take 20, add it to B, and update the result in B. We can also do something like this if we have C modulus 20, and then we store the result in C. We again do the same thing. We simply take this sign, put it on the left side. So we have C modulus and then an assignment as well as a 20 there. This applies for all other mathematical operators that we have talked about: a multiplication, a division, a subtraction, as well as an addition. So what I'm going to do quickly is I'm going to take you back to NetBeans so that I can show you how we can do those things in NetBeans. All right, so I'm going to remove these things. Right, so here what I want to do is, I want to write, you see, a statement like this one, This would give us a 9. We are taking what is in A, we add it to B, and then we overwrite what is in A. So as say 4 plus 5, we get a 9, and then we overwrite it. So this statement can also be written as A plus, and then B, like this one. So we can go on and display what is now in A. We can write system.out. Like this. So if I display here in A, we should be having a 9. Okay, we have a 9 there. It's showing the same line as build what because I didn't use print ln. But if I had used print ln, this message was going to be on a new line. So like I said, for any mathematical operator that you can think of, if we have a situation where we have what is the left operand appearing on the right operand again, we can simply combine those operators. Like here, if we wanted to say, write something like this, this is the same as this one. Same as this one. So this means take what is in B, multiply it by what is in A, and store the result in A. So this is going to give us a 20 because it's now 4 times 5. So if we run this one, we should get a 20 below here. We should get a 20, which is what we have there. So basically, like I said, this applies to all the operators, whether it's a modulus, whether it's a subtraction, it's a multiplication, etc. However, this is not the same as this. So you cannot take this operator, this asterisk, and put it on the right-hand side. We put it on the left-hand side like this. So that's how we do it when we combine multiple operators, or when we combine assignment operators. Now, we also have increment and decrement operators. An increment is just a plus plus. A decrement is a minus minus. So a plus plus is the same as plus 1. A minus minus is the same as a minus 1. So before I go back to NetBeans to demonstrate that, let me just also talk about the relational operators, which we use for comparison or for mathematical comparison. We have is equal to, which returns true if what is on the left is equal to what is on the right. This one, it means not equal to. This one is greater than, less than, greater than, or equal to, less than, or equal to. So those are relational operators. Okay. So having said that, let me take you back to NetBeans so that I can show you how we can do it. Just take you back to NetBeans and show you how we can use those ones. All right. So let me start with when less than or equal to. I'm going to use an if to do that. So here I can say if A is less than B, like this. If A is less than B, then let me display system dot. Then let's say B, like this. Okay. So this is going to display a message. System dot out. So this is going to display a message where it will say, it will display the number and then is less than, and then displays the number. So in this case, we expect it to show the message 4 is less than 5. Okay, so let's run that one and see. Yes, it shows 4 is less than 5. We could also say if 4 is less than or equal to, okay, it's still going to say, to display the same message, 4 is less than 5. All right. Now, we could do this. This is a greater than, okay. If you want an equal, this is an equal to. If you want a not equal to, this is our not equal to. So in this case, if we run this, it will show 4 is less than 5. But anyway, let me say dash is not dash, like this. And then it's going to display the message 4 is not equal to 5. So we have greater than or equal to, we have less than, we have less than or equal to, we have not equal to, right, all those ones. Okay, so then we also have increment. Increment, that's a plus plus, and decrement is a minus minus. So in terms of the increment and decrement, we have what is called a prefix increment. Right. Remember, pre means before. So when we use a pre, it means we are going to increment the value before we do the operation. For instance, let me write a statement like this one, and then plus plus b, and right. Then maybe say plus c. Right. So this one plus plus b. It's like we are saying 1 plus b. So 1 plus b, we expect it to be 6 because b is 5. So this becomes 6, and then we say 6 plus 2, and then we get an 8. Now, because this plus plus is coming before b, it means it's a prefix increment. So we increment b first before we can use b in this operation. So if we display the result of a, after doing this, if we display the result in a, we expect a to be 6 plus 2, which is 8. So let me do this. Let's do this to display result in 8, like this one. So if I do this, we expect to see we should be getting an 8 in A, right? And here we get an 8 because we used a prefix increment. Now, if I use a postfix increment is like this. So this is the same as saying, maybe let me put brackets for some of you, if you think this will confuse you. this is B++ and then C. Okay, so I'm going to remove them because we have seen that. So this is B++, and then now this is a postfix increment, which means we are incrementing after. So when we have a postfix in a statement like this one, it means we are going to say B, which is 5 plus 2, we get a 7. And then after getting that 7, we then increment B, which means this increment is not going to be used in this operation. If we display what is in A now, if we display what is in A, we expect it to be 7 and not 8, as you can see here. In A, we have 7, not 8, but B has been incremented by 1. It has been incremented after its value has been used in this expression or in this mathematical expression. Okay, so that's the same concept applies to decrement. For a decrement, if you want to reduce by 1, it's going to be B minus minus. It's going to be B. So B minus minus, or you could say minus minus B for a prefix decrement operator. Okay, so that's that as far as these increment operators are concerned. Okay, so let's go back and look at the other operators. So we want to look at we have already looked at relational. So let's look at logical operators. For logical operators, we have the logical AND, we have the logical OR, we have the logical XOR, which is the exclusive OR, we have the short circuit OR, the short circuit AND, we have the logical unary NOT, which is, and then we have an equal to as well as a not equal to. We've already looked at equal to, not equal to. So let's look at AND, which is the logical AND. Now, the difference between this logical AND and the short circuit AND is in how the operation occurs, not necessarily in the result, but how the operation is occurring. With the logical AND, which is this one, and this is a non-circuit AND, and then with the short circuit AND, okay, the difference between this and this is that with this one and this one, they work the same way, but the difference is in that suppose we are saying true and true and false, and then suppose maybe we also have false and suppose we have false and true. Okay, if we have a scenario like that, one where we have if we are using AND, we know that for an AND to be true, both of these ones must be true. So one of these ones looks at this one. If it sees that this is true, then it goes on to check the next one. Now, if it sees that this is false, it stops, because if this is false, it means the whole expression is going to be false. There's no need to check the second operand to see if the second operand is also going to be true. Or with the short circuit, it only performs, or it only checks the second operand if it's necessary. That's the short circuit, like this one. It only checks the second operand if it's necessary. This one always checks the whole expression. So that's the difference. Like saying, you look at this one. If we are using an AND like this, let me say true and false, right? Then false and true. When you are using this one, it always checks both of them. We know that with an AND, for it to be true, both of them must be true. So it looks at this one, and then it also looks at this one. But in this case, you can tell that this is a false, so the whole thing is going to be false. But because you are using this one, which is a not short circuit, it's going to check everything. However, if you use a short circuit like this one, true and false, which is the logical end. If you do this, this will only check this one when it is true, like when it is necessary. Like in this case, it is necessary to check this one because the first one is a true. So there is a possibility of this expression becoming true. So it goes on to check this one. However, if we have an expression like this one, the moment it sees that this is false, it doesn't go on to check this one because this whole expression is going to be false since we are using an and. The same goes for this one, logical or and short circuit or. They both give the same answer, but the only difference is in the mechanism in which they are implemented. With this one, it always checks all of them. Like say, if we say 1 or 0, in other words, we are saying true or false. When we use this one, the logical, this one, which is not a short circuit, like if you write 1 or 0, we know that when we use or, the moment this one is 1, the whole expression is going to be 1. However, when you use a not short circuit, it's going to also evaluate this one. If you use a short circuit or, which is this one, the moment it sees a 1 here, and then there is an or, it doesn't go on to check what comes after it because it knows that this is an or, so this whole thing is going to be a 1. Okay. So that's the difference between them. So you can tell that this is not very efficient compared to this one, because this doesn't waste time checking other things. It only checks the whole expression if it's necessary. So this becomes faster now compared to this one when you are implementing them. But in terms of the results that they return, they will always be the same. Okay. So for instance, let me show you again in NetBeans how we can use those operators. Let me do this. Let's say we want to use an if. So we want to say if A is greater than 1, right? If A is greater than 1, or B is greater than 6, right? Something like this. Let's just say maybe it's going to display the message hi. Let's just display the message hi. In this case, because we are using this one, it will check this part and it will also check this part regardless of what we get here. Is A greater than 1? From this one, yes, A is greater than 1. So we expect it to display this one because this part is true and this is an OR. But because we have used this type of not short circuit OR, it's also going to check this one, which takes more time. Now, if you run this code, you realize that it will display high. Okay, it will display high. But in terms of the efficiency, this one is not so efficient. You can do this now. Again, this is going to display high, but what happens when you do this is, if it evaluates this one, it sees that this is true, it goes on to display this code without having to worry about this one. It won't even check this one. So you see, if we run this code again, we are still going to get the same result here. We still get high. Okay. The same applies with AND. This is the not short circuit. So if you run this one, right, this is not short circuit. So we are going to get the same answer. Okay. If you use again the short circuit, we'll get the same answer. But the only difference is in terms of the efficiency, the time it takes for your code to achieve what you want to do. That's where the difference will be. So I hope that's clear enough. So let's go back to NetBeans, to our notes and look at the other. Let's just use this one as an example to illustrate. Now, let's suppose we have these inputs, A and B, with these particular values. Right. This is A, not short circuit B. So that's basically I mean A or B, which is not short circuit. This is A and B, which is not short circuit. This is A exclusive or B, and this is not A. So A or B, remember, for A or B, both of them, if both of them are false, A or B is also false. If one of them is true, A or B is true. If one of them is true, A or B is true. If at least one of them is true, A or B is true. Then A and B, it's only going to be true if both of them are true. So both here are false, so it's false. One of them is false, so it's false. One of them is false, it's false. And both of them here are true, so it becomes true. A exclusive or B, A exclusive or B, it means that it will only be true where where the values of A and B are different, right? Where the values of A and B are different, that's when we'll get a true. So here, A is false and this is false, so they are not different, which means we'll get a false. True and false, they are different, so we get a true. False and true, they are different, we get a true. True and true, they are not different, so we get a false. Then not A, it basically negates A. So when A is false, not A will be true. When A is true, not A will be false. When A is false, not A will be true. When A is true, not A will be false. Okay. So that should be, you should record this from your computer, I mean the mathematics one, as well as CSA. Is it? I mean that one where you did circuits, the other module in which you did circuits. Okay. Then, okay, we have already looked at something like this one. This is just, we are combining two operators here and then assigning the result. So we have already looked at something like this one. So I'm not going to spend more time there. Right. Let's look at this one, which is called the ternary operator. The ternary operator, the syntax is, we have type variable, and then we have an expression that we are evaluating, and then value if true, colon, value if false. Right. Let me show you what this one means and what it does. Quickly, let me go to NetBeans. Okay. You see, in NetBeans, we can have, let me take this if statement. Right. You see this if statement as it is, exactly as it is. We can have an else here, and then we can put an else and then system. So print. And let me say hello. Okay. In this case, we are saying if this condition is true, then we want the computer to display hi. If this condition is not true, we want it to display hello. We can use a ternary operator to do this. So the syntax of a ternary operator, we can just do this. Let's have a variable here, and then we do this, and we will say condition. This is the condition. If it's true, we want the value if true, and then value if false. So if you look at this one, the condition that we have is here. So I'm going to take this one as the condition. Now the value that is going to be returned, it's either hi or hello, which are strings. So I'm going to create a variable that will store those strings. Let me just say string temp, it's just a variable. And then I will do this. Now, this is the condition. We are checking it. Now, what is the value if true? If true, we want a hi. If false, we want hello. Now, we can go on and print, go on and display the value that is in temp. So in this case, I'm not going to remove this if. I'm going to have both of them remain there. So we are expecting to see the same answer twice, because what we are getting from this if-else statement should be the same as what we are getting from this ternary operator here. This one is a ternary operator like this. So I'm going to run this code, and we should get the same result twice. So you see, hello, hello. Right. The reason is we are saying, let me start from here. If A is greater than 1, which is true, and B is greater than 6, which is false. So we are not going to execute hi, we are going to execute hello. Again, here we are saying, if A is greater than 1 and B is greater than 6, this store hi in temp, else store hello in temp, and then display what is in temp. And again, it also displays hello. So this is called a ternary operator. It's basically a shorthand or a shortcut for an if-else statement. All right. So it's the same as an if-else statement, this part. So let's go back to our slides and look at the other operators as well. Okay. So for the bitwise operators, we now look at the other category of operators where we have a bitwise operators. And these ones act upon individual bits of either operand in integer form. So we have the AND, which is a bitwise AND. We have OR, which is a bitwise OR. And then we have that one, which is a bitwise XOR, bitwise complement, left shift, right shift, zero fill, left shift, etc. Okay. So let me illustrate that one with an example. Okay, I'm just going to use examples to illustrate all these ones: left shift, right shift, bitwise AND, bitwise OR, and then yes, and then we can end this presentation. All right. So let me do this. Let me come back here. I'm going to delete everything that I have here. I'm going to delete everything that I have here. For this example, I'm going to use binary numbers so that you can easily visualize what we are talking about. Let's say int A. I'm going to initialize int A to a binary number. Let's say 1010, which is 10. And then let me initialize, let me have another variable B and initialize it to maybe say 101. 101, like that one. Now, I'm going to use an AND. So I'm just going to display the result onto the screen. I'm going to say AND. This is a bitwise AND, A and B. So that's a bitwise AND. And we get a 0 there. Why are we getting a 0? A bitwise AND, we are saying 1, this bit 1 from the left, this bit 1 and 0. That's a 0. 0 and 1 is 0. And then we come here 1 and 0. That's another 0. And then here we have 0 and 1. That's another 0. Now this is 4 bits. And this is 3 bits. So here we will have another 0 so that there will be 4 bits. So we'll say 1 and 0 and it will be 0. That's why we are having a 1 there. Let me change this one and maybe make it 4 1s like that. And still using the bitwise AND. This is going to be 0 and 1. That's 0. 1 and 1 is 1. In fact, we are going to have ones where we have ones here and then zeros elsewhere. So if we run this one, we get a 10. Why are we getting a 10? It's because we are saying 0 here and 1. That's 0. Okay. 0 and 1. Maybe let me put it, let me do it like this. Let me just do this. The first one is 1 0 1 0. That's our A. And for B, we have It's 1, 1, 1, 1. Now, when we use the bitwise AND, it's 1 and let me illustrate it here. Let me just annotate like here. We're saying 0 and 1, that's 0. Then we have 1 and 1, it's 1. 0 or 0 and 1, it's 0. And then 1 and 1, it's 1. Now this number is in binary. If you convert it to an int, that's a 10, because this is a 1, this is a 2, this is a 4, and this is an 8. So we have a 1 for an 8, which means we have an 8, so that's 8 plus. We have a 1 for 2, so that's 8 plus 2. The other 2 are zeros, and 8 plus 2 will give you 10. Right. So that's why we are getting this 10. So that's the bitwise AND. If it was the bitwise OR, like here, if we do this one, that becomes the bitwise OR. In this case, you see here, this one is all ones, which means we are expecting this number to be the answer here. So these ones are 4 ones. This is an 8. We expect to get a 15 if we run this code. So let's just run it and see. Sorry, what is the issue there? Oh, sorry. It's because of these lines that are introduced here for demonstration. So we do this and we get our 15 because this is a bitwise OR. So I assume everyone knows how the bitwise OR and bitwise AND works, okay, from binary algebra. So basically, this is what we wanted to cover as far as operators are concerned. So I think we can now end it here. Let's meet in the next video. Thank you.